There's a gray powder that costs $2 at any garden or hardware store. It seals a leaking pipe permanently on first contact. It does not crack, it does not shrink, and it does not require a single tool to apply. The older the leak, the harder it locks. It has been used for over 2,000 years. Roman engineers lined entire aqueduct systems with it. The nuclear waste storage industry uses it today as its primary containment barrier because nothing synthetic performs better at sealing water permanently. And licensed plumbers have been charging you $200 to $800 for repairs that this $2 mineral handles in under an hour. They did not stop using it because it failed. They stopped teaching it because it worked far too well for far too long at far too low a cost. A powder that seals any leak permanently for $2 cannot generate a service call, and what cannot generate a service call cannot generate revenue. This is the complete story of bentonite clay, the mineral the plumbing industry quietly removed from every DIY guide after 1960, and the two industries that depend on you never learning its name. Welcome to the Blueprint Secrets. This is where we open the vaults that billion-dollar industries need permanently sealed. If this knowledge matters to you, subscribe and hit the bell right now. Every vault we crack open, you will be the first inside. Let me take you back to roughly 300 BC. Roman engineers are solving one of the most demanding infrastructure problems their civilization has ever faced. They need to move clean water from distant mountain springs into a city of over 1 million people. The channels must hold water under constant pressure across dozens of miles of uneven terrain. Any crack, any gap, any failure point means contamination and loss. They already know stone and mortar alone will not hold. Groundwater seeps through joints. Tree roots crack the channel floor. Seasonal freezing splits the mortar apart. So Roman engineers developed a lining system using a mineral they found in abundance across the volcanic regions of central Italy. They packed it into every joint and layered it across the channel floor before setting the stone above it. That mineral was bentonite clay. What the Romans understood through observation and what modern geochemistry has since explained in precise molecular terms is that bentonite behaves unlike any other material on Earth when it contacts water. It does not simply absorb moisture the way soil or sand does. It swells. Bentonite clay expands to 15 times its dry volume when saturated. It fills every gap, every crack, every void around it with a dense plastic mass that water cannot pass through. And as it dries and re-wets through seasonal cycles, it does not crumble or shrink back permanently. It tightens. Every wet cycle locks it further into the surrounding material. Roman aqueducts lined with bentonite outlasted the empire that built them. Sections of the Aqua Claudia, completed in 52 AD, were still carrying water through bentonite-sealed channels more than 4 centuries after Rome fell. Not because the Romans had better engineering resources than we do today, because they had a material that genuinely worked and no financial reason to replace it with something more expensive. That reason would come later, much later, and it would not be scientific. Here's exactly why bentonite clay does what no synthetic sealant on any hardware store shelf can replicate, and why understanding this changes how you look at every pipe in your home. Bentonite is a naturally occurring aluminum phyllosilicate clay. Its primary mineral component is montmorillonite, a layered crystal structure that carries a permanent negative electrical charge across its flat surfaces. Water molecules, which carry a slight positive charge, are drawn to those surfaces and forced between the crystal layers. This is not simple absorption. This is a chemical attraction that physically separates the crystal layers and forces them apart. The result is expansion. Measured in a laboratory under controlled conditions, sodium bentonite, the most common variety, expands to between 10 and 15 times its original dry volume when fully saturated. That expansion generates a compressive pressure of up to 700 kilopascals against surrounding material. That is roughly the same pressure as 100 pounds per square inch pushing outward in every direction simultaneously. Now, picture that pressure working inside a cracked pipe joint, a hairline fracture in a water channel, or a gap around a pipe penetration through a foundation wall. The clay does not simply fill the space. It compresses against the edges of the crack with enough force to physically close it from inside. And because the expansion is driven by the presence of water, the seal tightens automatically every time the leak attempts to push water through. This is why the nuclear waste containment industry trusts bentonite over every synthetic liner ever developed. The U.S. Nuclear Regulatory Commission specifies bentonite clay liners for low-level radioactive waste containment sites across the country. Not because it is cheap, though it is, but because a material that self-seals in the presence of water is exactly what you want surrounding something that must never leak. Independent laboratory testing published in the journal Geotechnique confirmed bentonite clay liners maintain hydraulic conductivity below 1 × 10 to the negative 9 meters per second, a permeability rating lower than solid granite. A $2 bag of powder performs better than engineered synthetic containment barriers that cost hundreds of times more per square meter. The science is not debated. The physics is not disputed. The only thing the plumbing industry disputes is whether you should ever find out about it. Now look at the numbers that the plumbing industry counts on you never sitting down and examining. The global plumbing services market is valued at over $130 billion per year. In the United States alone, the average household plumbing repair call costs between $175 and $450 for a standard leak repair. Emergency calls after hours run $500 to $800 or higher before any parts are touched. Licensed plumbers bill at $45 to $150 per hour, depending on the region and the job complexity. A leaking pipe joint, a seeping foundation penetration, a weeping irrigation line, these are the calls that drive that $130 billion, and every single one of them is a candidate for a repair that costs $2 and takes under an hour with no license required and no tools beyond a container of water. You cannot patent bentonite clay. It formed in volcanic ash beds millions of years before any plumbing company existed. You cannot trademark Montmorillonite or build a proprietary version of a mineral that occurs naturally across 6 continents. You cannot create a service contract around a bag of powder anyone can buy at a garden supplier or pool supply store. And so the industry did what industries always do when a cheap solution threatens an expensive one. They did not ban it, they did not disprove it. They simply stopped teaching it. Plumbing certification programs removed mineral sealing from their curriculum after synthetic epoxy compounds and mechanical repair clamps entered the market in the 1960s. Home improvement television never covered it. Hardware stores stocked the $18 pipe repair tape and the $24 epoxy putty at eye level and moved the bentonite when they carried it at all to the garden aisle under the label pond liner sealant, where no homeowner with a leaking pipe would ever think to look. The knowledge did not vanish. It was simply relocated to a shelf where the wrong problem would never find it. This knowledge never disappeared from the people who needed it most and had the least access to alternatives. In rural farming communities across the American Great Plains, bentonite clay has been used continuously for pond sealing and irrigation channel repair for generations. Agricultural extension offices in Kansas, Nebraska, and Oklahoma have published application guides for bentonite pond lining since the 1940s. Farmers who could not afford to drain and re-excavate a leaking pond simply spread bentonite across the dry bed, refilled it, and watched it seal within days. Some of those ponds have held water without reapplication for over 40 years. The golf course industry quietly relies on the same material. Artificial water hazards and ornamental ponds on golf courses across the American South and Southwest are routinely sealed or resealed with bentonite rather than synthetic liners, because the cost difference over a large surface area makes synthetic options financially indefensible. The material that costs $2 for a household repair costs thousands less than synthetic membrane at scale. And then there is the application that makes the nuclear industry's continued trust in bentonite the most telling detail in this entire story. The Yucca Mountain Nuclear Waste Repository Project, the U.S. government's primary proposed site for long-term radioactive waste storage, specified bentonite clay buffer zones as a primary containment barrier in its engineering design, not as a secondary backup, as the primary barrier between stored waste and the surrounding geology. Engineers with access to every synthetic containment technology ever developed looked at all of them and chose the same gray powder Roman engineers packed into aqueduct joints 2,000 years ago. If you have made it this far, you already know more about pipe sealing than 99% of homeowners who have ever paid a plumber. Subscribe and share this with someone still scheduling a service call for a leak that a $2 bag can fix this weekend. Everything the plumbing industry buried is in the vault. The link is in the description. Stay with me, because what comes next is exactly what they need you to never actually use. Here is exactly what to do. And first, what this works on and what it does not. Bentonite clay works on slow seeping leaks at pipe joints, cracks in concrete water channels, gaps around pipe penetrations through foundation walls, leaking garden ponds, and irrigation line connections. It works best on low-pressure passive leaks where water is seeping rather than spraying under high pressure. It is not a fix for a burst pipe under full line pressure or for joints inside finished walls with no access. But for the category of leaks that generate most residential plumbing calls, seeping joints, weeping foundations, dripping irrigation fittings, this is the method. Step 1. Buy sodium bentonite clay powder. It is sold in garden centers and pool supply stores as pond sealer or pond liner clay. A 50-pound bag costs between $15 and $25 and covers far more repair than any single household job will require. For smaller applications, some suppliers sell smaller quantities. The cost per repair job works out to approximately $1 to $3 of material. Step 2. For a pipe joint or fitting leak, dry the area around the leak as completely as possible first. Pack dry bentonite powder directly into and around the leaking joint. Use your fingers or a putty knife to press it firmly into every visible gap and crack around the fitting. Step 3. Wrap the packed area tightly with wet burlap or a soaked cloth and hold it in place with wire or zip ties. The wet wrap begins activating the clay immediately. The bentonite starts expanding within minutes of contact with moisture. Step 4. Allow 24 hours before restoring water flow to the repaired section. During that time, the clay expands fully into the joint geometry and begins compressing against the pipe surfaces. After 24 hours, restore flow slowly and check for seepage. In most cases, the repair holds completely on first application. For a foundation wall penetration, a pipe passing through a concrete or block foundation that seeps around its edges, pack dry bentonite into the gap around the pipe from the interior side. Dampen lightly with a spray bottle. Allow 48 hours before checking. The clay will swell to fill the penetration gap completely. For a leaking garden pond or water feature, drain the pond to expose the leaking area. Spread dry bentonite powder at a rate of approximately 2 pounds per square foot across the leak area and any surrounding suspect zones. Refill slowly. The clay activates as water rises and seals the leak from below as pressure increases. Total material cost per repair, $1 to $3. No license required, no special tools, no service call. Roman engineers packed this gray powder into stone joints in 300 BC and built water infrastructure that outlasted their entire civilization. They did not have synthetic epoxy. They did not have repair tape or mechanical clamps. They had a mineral that swelled when it touched water and sealed whatever gap it filled. That was enough. It was more than enough. The nuclear waste containment industry looked at every synthetic option available after a century of material science development and chose the same mineral for its most critical sealing application. When the question is whether radioactive material stays contained for the next 10,000 years, engineers do not pick the product with the best marketing budget. They pick what works. This knowledge did not disappear because the clay stopped performing. It disappeared because a $2 repair cannot share a market with a $130 billion service industry and be allowed to spread freely. The knowledge was not banned. It was not discredited. It was relocated, moved to the pond liner aisle of the garden center, relabeled for a different application, placed somewhere a homeowner with a leaking pipe would never think to look. The bag is still there. It has been there the entire time. The same material the Romans used, the same material nuclear engineers specify today, sitting on a shelf in the garden section while a plumber schedules a $400 service call for the following Thursday. Some knowledge does not die. It simply gets moved to the wrong aisle. Today, you know which aisle it is actually on. If this vault opened something for you, subscribe and share it forward. Every share keeps open what the industry spent decades quietly relocating. The next vault opens soon, and what is inside weighs even heavier.